About this intermittent dimensions where you can have different 6 tools typical location, and this is the diameter of the holes 20 plus minus 0.2. So what happens if I'll go for this? So position of this hole is loser tolerance where I'm giving a 5 mm and I'm giving a secondary control for 0.5 for axis interpretation, axis obbling, and this is basically the whole features movement, diameters movement, and this is axis movement, that is 20. So 20.2 is the overall diameter where 5 mm deviation is allowed, and this 0.5 is between this center to center. That means this is tighter. So in this way you can instruct and encode the whole process based on your requirement. Now if you see the full GD&T part, now this is done, and now some of the highlights here. Why the modifier S is used? The S is used is for the regardless of feature, as I discussed in my earlier session today. So regardless of feature is even this size somewhere this diameter is 20 but this is 18, still you can apply the regardless of feature. Regardless of the feature you can have a axis alignment. Here this axis need to be aligned even though this diameter and this diameter are different. So the gist is the M modifier you can use for the clearance. The L modifier, the least material condition, you use for interference and overlap. So we don't use in manufacturing a GD&T, M only we use. And S is basically for centering and aiming. If you want to center objects, then we use S. So this is the primary objective. So more GD&T detail you can find like compounding and composite scenario. And if you refer the Y14.5 2009 manual or ISO 1101, there you will get a detailed explanation about compounding and composing. But in general, the compounding and composing cater to the same case. So is there a difference between this? So in this particular case, there is no difference, but because of the time limit, I'm not going to discuss this. So how does this GD&T do a stack up? If you talk about the GD&T latest code, there is an envelope rule, which I told before that I will discuss about the rules also, which guarantees the assemblability. The envelope rule is, even though I have a bore size somewhere 20, one were 18, one is 12, but still the axis alignment can be referred by using the regardless of feature size S, the S modifier wherever you use. That can be applied to datums, that is regardless of feature boundary, and if you use for the feature, that is regardless of feature size. So M meaning or L meaning are quite different. Most of the people, they get confused and wrongly interpret. And coordinate system also is a primary part inside your system. So if you have a primary coordinate system, every independent features are getting referenced because of this giving tolerance with respect to the primary datum. This is across the axis to axis. This is independent holes. This independent hole can get varied, and this is tighter tolerance from axis to axis, because this is critical, because across the counterboard we are going to assemble your pins, but alignment is critical for us. So if in your case alignment is not critical, you can keep a tighter here and looser here, that depends. So you can go for the tier 1 and tier 2 design, and this is what it will happen if you go for the variation. The mobility of the datum can rock, and they can still be within the limit, and your part will not be rejected. So even though most of the people they think that this is a complex process, and I used to say that when I visit different companies and their design and inspection team and manufacturing people I used to discuss, they used to have a common misconception and they communicate in different way based on their interpretation. So never interpret GD&T. Try to understand, and it always gives you a cylindrical zone, not a square zone like your earlier conventional method. So we get a typical cylindrical zone. So in addition, GD&T also provides powerful tools for controlling compound curved surface, powerful tools for managing feature forms, so where during this process I have not discussed, and powerful means for researching and refining the part functionality. Exactly, you can research and refine the part functionality wherever you have problem, and you can guarantee function and fitment. And also the ability to reliably do the tolerance stack up and guarantee assembly operation and function. So as a result, GD&T liberates us from tribal understanding and interpretation. These both are the wrong words.